last time we were looking at spawning all the prefabs, adding UI for spawning these things, right? I give you a few assignments. The assignments were to allow multiple prefabs to be selected rather than one, right? Because now every single thing that we spawn is just the same thing, but we might want to randomize between these in case we have, you know, multiple different types of foliage, multiple types of trees, and so forth, right? By the way, I changed a few things when it comes to positioning objects within this circle. You know, we talked about tangent space. So you can see this little gizmo in the center, right? So that one is representing tangent space. And previously we were sort of manually transforming things, you know, from tangent space to world space, because our random points are generated in tangent space, right? They're in this like unit circle, and then we transform them to the world so that we then know, you know, where to place them. I replaced some of that code so that it's now actually using a matrix to do that, because we talked a little bit about matrices, right? So the things that I changed was that when we raycast onto the world to find the first position, you know, the one in the cursor, then we set up all of these vectors, right? For the normal, tangent, bitangent, and whatnot. So if we then want to transform things from tangent space to world space, then we can use a matrix for that. So I set up a matrix for the point you hit, and then the rotation that we get from all of these different direction vectors, right? So we can do that with quaternion.look rotation. So as usual, the forward vector, which is the first parameter of this one, is usually the z-axis, and the z-axis is usually the normal of the surface. And then the y-axis, or the up vector, is going to be the bitangent of the tangent space. So I also cleaned up a bunch of this code. So if you wanted a more like clean version of this entire script, you have that now as well. So I just, you know, put a bunch of things in functions and separated them out, so it's not like, you know, this massively long file, right? So try raycast from camera, for instance, is a new function. And then instead of like having that code in the update loop, that is now instead in a separate function. So during scene GUI is now relatively short. So now it has the try raycast camera here, or from camera here, where it's doing all the raycasting, and if that works out, then it generates a spawn position, it draws a circle, it draws the spawn previews, and then you spawn the objects if you press a key. So I've separated everything out now. I hope it's not too confusing that it did that, but I figured it would be good to like try to clean something up every now and then to stick to some sort of like good code, right? Because it started becoming unreadable. So that's why I did some cleanup. Yeah. Okay, so let's look at spawning multiple different types of objects. So currently we have these like checkboxes that we could like click to select the different items, right? But it's only selecting one of them. So I imagine that allowing multiple objects, you would just be able to select multiple of them, then you could untick them as well, right? Okay, so in order to do that, we need to retain some sort of selection state of what objects have we selected, right? Right now, we don't save that at all anywhere. So we need that. All right, so to save that, we could use a bool array. So this is going to be our selected prefabs, right? So then we have 3 prefabs, and then it's going to be a bool array. So it's going to be an array where every element is either true or false, depending on whether or not it's selected, right? We could also make sure to serialize this field so that we don't like drop the data if we recompile the scripts. All right, so after we load the prefabs, this is where we want to set up the bool array, right? Because that's when we know how many items we have, and that's kind of the initialization of all the items that we've got, right? So we want to set up selected prefabs, and right there. We could actually check if it's null here. We could check if it's the wrong length if we want to be more proper about this. Because otherwise it might actually reset. There we go. So if it's null or if the length doesn't match the amount of, items we have, then we reinitialize this array. So it's going to be a new bool array with the amount of prefabs that we got, right? So now we've loaded the bool array, which is going to contain the selection state, right, of all the prefabs. Because we could have an array of all the objects we have selected, right? But then the selection state is going to be secondary and have to be calculated. So either we calculate the selection state or we calculate the objects we have selected. I don't know which route we should go, but let's go with this one. Because the UI loop is going to run many times, so maybe it's good to make sure that the UI loop has the data it needs. Because in that case, the selected prefabs, the selection state is going to be the important part. So maybe we should rename this prefab selection states. Is it not better to use list for adding and removing? We're not adding and removing to this one because there's a fixed amount of prefabs, right? So then we just set, whether or not it's selected on this bool array, right? Because we need that state in the UI to read off of all of these states. We could have a list, but then every time we need to check if something is quote unquote selected, we need to check if the list contains that object, and that doesn't scale super well. So that's why I was slightly preferring this one. You could probably set up both, but yeah. This is going to be in the scene view UI, right? They're in the top left of the scene view. So then we should go to the during scene view GUI. And here are all of our icons, right? So currently we are iterating through all the prefabs, and we might want to convert this to a for loop. Because we need the index in this case. We need the index to access the bool array to check the selection state. So then for every iteration, we need to check the current state, right? So GUI toggle has the current state that it's displaying here. So that's going to be prefab selection states I. And then we also want to assign that to GUI.toggle, right? So we could do prefab selection states equals GUI.toggle. So now we can, now we have all of these selection states, right? But we're not actually updating the prefabs that we're spawning. So this needs to happen conditionally, right? And this is actually going to be multiple objects, right? So this is going to be, we can make this a list. Let's just call it spawn prefabs with a plural. So we can do if editor GUI dot begin change check. So this one is going to start checking if something has changed. So we can actually no if statement. And then after the GUI.toggle, we can do if editor GUI dot end change check. If that's true, then something changed. So that's what we want to check here. As in, did you change this toggle, right? And if you did, we want to update the list of selectable objects, right? I was thinking we could do add and remove, but I'm not sure if that's going to be... actually should be... Or maybe it's not stable, actually. We might not even have to do this, actually. We don't need to check for change, so never mind. But if you do want to check for change in like editor controls, you can do it like this. But yeah. Actually, I still want to do that. It's probably good. Let's have that up here. Spawn prefabs. Sorry for being back and forth with things. I'm just gonna like brute force iterate through the entire like bool array and then re-add everything rather than like trying to get the add and remove states valid and whatnot. I feel like it's kind of prone to bugs in this case, so I'm just going to be lazy. And this only happens when you change selection, which doesn't happen all that often. So if there's even a tiny bit of lag spike when you click something, it's not going to be a big deal. Not until you hit like, I don't know, 5,000 prefabs, in which case you have other UI issues to deal with. So let's see, prefabs dot length. So we're going to do spawn prefabs dot add, and then we are going to add where selection states I, where that one is actually selected, right? So that's when we want to add the current prefab that we're looking at, which is this one right here. No, wait, actually, no. Prefabs I, there we go. What does writer want to do with this? Oh, I guess you can do that, sure. But I don't want to. Oh, right, it should be J, not I, sorry. Because it's the inner loop that we're going through. Okay. I just want to make sure that this works. Right, because we converted a thing to a list, so a lot of these things are not going to work now. So we said spawn prefabs here. So let's do spawn prefabs 0 or something. Index out of range exception. That's okay. All right. So now you can see that we can select multiple things here, right? We can untick and tick stuff. And it looks like our selection list is updating. It doesn't handle having nothing selected. So we need to make sure that there actually are spawn prefab selected. There we go. So now none of them are selected, but we can still, you know, move the cursor around and all that stuff. So we can select little capsules, select the rocks, and so forth. But right now it's only using the first one, right? So it's not like caring about our selection. It's just picking the first one in the array, which is kind of defeats the whole purpose of doing this, right? So what we need to do now is that we need to randomize which mesh it's using per spawn point, right? And the way we do that, we need to be careful with how we do that again, right? Because remember when we were randomizing the rotations, then the trees were like flickering every single frame, right? They were like spazzing out. So we don't want that to happen, right? We want to make sure that the randomization of what prefab to use doesn't happen every frame. So the way to do that is using the spawn data that we had, right? Spawn data was kind of our fixed data that happens for every update of all the like positions of all the objects, right? So that would be a good place to also save what mesh to spawn, right? Or sorry, what prefab to spawn. Gamer objects. So now prefab is going to be part of spawn data. And then set random values. We want to set it to a random prefab, right? Right, actually, we have to pass that in. So then we need a random element in this list, right? So then we do spawn prefab equals prefabs, and then random dot range 0 to prefabs dot length count. Sorry. Make sure this one is using the integer one. Let's see. Wait, why is that one not showing the... Anyway, make sure you use the integer one, because the integer one is exclusive, as in it's not gonna... prefabs.count is not gonna be returned as a value, but everything before, from 0 to prefabs.count minus 1 is gonna be returned by this. So we're getting a random index, but it's excluding this one. In float, I'm pretty sure it's inclusive. Random.range. Yeah, it says so here. Inclusive and inclusive for min and max. But if it's integer, that one says exclusive for the max value. So the max value is never going to hit in random.range. All right, which is what we want here. All right, so now generate random points now actually needs to read from that value, right? So set random values, we're going to pass the spawn prefabs into that one. So try spawn objects. This one has a bunch of poses. So I guess we kind of need not only the post data here, but we need the actual original random point, right? Hey, hi. Are you heading out? Great. Have a good trip. I'll see you soon. Right, so we're gonna call try spawn objects, but we don't have the actual points here, so we need those. Do they line up? They should probably line up. Oh, don't cancel. I did not want to go there. So we're getting the spawn poses here, which is iterating through the spawn data. So right now we don't actually have the spawn data in our poses, right? So one thing we could do, this would probably be a good time to have a separate type for spawn point, right? So let's do that. And then we can refer to the spawn data, right? For the original data that we had for knowing where to raycast and everything. And then spawn point is the actual point that we hit with a raycast and all the data that goes into that, right? So now we're going to replace pose with spawn point. Because remember, pose has a position and a rotation, but it doesn't actually have... It's sort of like a transform, but without scale and without being a component, right? So far, I've understood when to use class or structs. This case should probably use class. Well, the biggest difference is just that structs are passed by copies of the value rather than a reference to them, right? So for things like numbers, you tend to not want to refer to copies of numbers, or you tend to not want to refer to the original of a field. So it's sort of like classes refer to some object, like a canonical object, whereas structs always copy the value every time you refer to it, right? So if you have... Okay, so if you do something like this, right? So in this case, you don't want this to be a class, because if you do this, then what is X and what is Y here? So if these are structs, which they are, right? They're value types, which means that when we set Y to X, we're actually copying the value from X into Y. And then when we increment Y, only Y is going to get updated. Y doesn't refer to X in this case. So X is still going to be 5 here, and Y is the one that's going to be 6. If this was a class or reference type, then what would happen is that Y is going to be a reference to the object that X is pointing to, and then even if we increase Y, then what's going to happen is that Y is going to be 6, but X is also going to be 6 because we only have the same data source for that, because they would be pointing to the same data source. But because they are structs, they are always copies every time you assign to them, or read from them, which is really useful, specifically for like vectors and math and that type of stuff. So for like small, lightweight, mathy stuff, you tend to use structs, and then for like everything else, you tend to use classes, right? Structs are generally a little bit cheaper because one of them goes on the stack and one of them goes on the heap, and one of them's cheaper than the other. But then it also like depends. Sometimes the copying of data can be more expensive than a reference, depending on how much data you have in them. So generally you want structs to be very lightweight and small. So yeah, there's a lot of like caveats that go into that, but yeah. Sorry for the tangent, but maybe it's useful. I hope it's useful. All right, so we want a constructor for this one. So let's do that. Also want to flip these around a little. All right, so where are we using posts? All right, let's change that to spawn points. We're not using that term, are we? Spawn data points, good, okay. So now we swap this out with spawn points, and we're probably gonna get an error. There we go, try spawn object, spawn poses, so let's call that spawn points. And then this needs to be a spawn point list. And then draw spawn previews also needs to use spawn points. There's a bit of a refactor. There we go. Oh, this one is doing spawn point dot up. So this one gets us the up vector of the spawn points, which previously this was in post. So now we need to actually implement this on our own, right? So let's make it that property. So that's going to be a vector. Let's call it up, and then we make a getter. And what we need to do in this one is that actually we can shorten this. So this property needs to give us the up vector of this rotation, right? So you can do that using rotation, and then you multiply by vector3.up. So if you want the up vector of a given quaternion, then multiply by that vector, by the up vector, and then you get that. And that applies to any vector. So if you want to transform, you know, just a direction by some rotation, then you can do that using multiplying that rotation by a vector with your direction, right? Yeah, so now I've kind of re-implemented the up property of the posts. So now it's reading from spawn point.up here, which is the one we just implemented. All right, let's see, still have some issues here. So get spawn poses probably returns the wrong type. So let's replace that. Let's rename this. Get spawn points. And this needs to be a list of spawn points. Let's rename this to hit spawn points. All right. So we set up a pose here, but instead of a pose, we're gonna set up a spawn point. And the spawn point needs a position, rotation, and this is the thing we did the whole refactor for. We also need the spawn data for this one. So because we need to refer to the original, like what was the information going into this specific spawn point that then led to us being able to calculate where to spawn this, right? All right, that was a bit of a refactor. Hope that was understandable. If I go too fast, let me know. I think I have a tendency to like do that without considering it. Okay, so far it seems to work, right? Nothing broke, so that's good. But we're still like using the old system that we had. Like nothing's changed. So we need to change a few things. So let's go to let's do the previews first. So draw spawn previews. This one is iterating through every spawn point, and then we need to check, you know, does this spawn point have a mesh in the first place, right? That's kind of what we were checking here. This was checking, you know, the valid prefabs to spawn, do they have items, right? But in this case, we want to check that on a per point basis. Or actually, we probably don't have to, but in this case, I'm going to check it in the spawn point. And in the spawn point, we have the spawn data, and we want to make sure that a spawn prefab exists, right? And then, so if that one is null, then we just draw, sorry, other way around. If that one is not null, then we want to draw the prefab, right? And then if it's null, then we just draw the little like gizmos that we had before. Okay, so now we made sure that the mesh exists. And then we need to actually draw, or the prefab exists, and then that's the prefab we want to draw. So instead of drawing the 0th prefab in the array, we're now going to draw the one that the data is referring to, right? It's a little nesty and like pointer diving into this whole thing. But remember that the spawn point is the calculated point that we find in the world, exactly where we want to place it, and with what rotation, right? The spawn data is the input data for how to calculate that position and how to generate that. So that this one kind of contains the metadata of the spawn point, right? And that one contains what prefab to spawn there. So if we go back, so now we've only got the rock selected. So if I select the trees, and then I might have to refresh the amount of points now. So set that to 19 or 190. And it looks like it works. We got a dense forest with just massive amount of rocks. Let's do a little lower. So now it's randomized between all these different things, right? So now we have trees and we have some rocks, and let's select the capsule. But now we don't have the capsule, right? Because the meshes that we have don't actually update when we tick this box, right? So let's fix that. And we don't actually have to recalculate the points when we do that. We could set up a function to just iterate through all the spawn points and randomize the mesh, right? Let's call it randomized spawn point meshes. Is the scene baked, or why is the light different? We're going to talk about that soon, actually. So we're going to iterate through all the spawn points. Right, we don't actually have the spawn points, now that I think about it. Because they're not cached. We would have to cache them in that case. Is that okay? Do we want to cache them? Or do we regenerate everything? We could go either way. I guess that's a design question, you know? If you swap out the, like, if you change your selected prefabs, do we want to, like, do we want to keep the pattern? Is that important? I'm guessing it's not super important. So the easy way to do this would be just to randomize all the meshes again, right? To like regenerate the points when you do a selection. So I think it's probably fine in this case. Plus it's easier to do, and efficiency is important. So this is where we update the selection list, right? So this is where we would also want to update the spawn point data, right? So we would do, what do we call it? Generate random points. There we go. So recompile, and there we go. So now we already got the little cylinders or capsules. So if we now untick the capsules, we just have rocks and trees. Untick the trees, we just have rocks, and now we have rocks and capsules, and so forth. Untick all of them. Let's see, we did get an error. So let's see where that happened. In our set random values. Okay, so we're passing an empty array in here. So we can check prefabs count here. So if prefabs.count, actually we might be able to do first or default. No. If prefabs.count equals 0, then that means that we have nothing selected, right? So then we just want to set this to null, because that's what we were checking, right? In the preview, we were checking, is it null or not, right? Yeah, and if it's empty, we assign null, and then we don't draw anything right there, right? Someone asked about how I set up the scene UI overlay stuff. That is in the next video on my YouTube. So I haven't uploaded the video from 2 days ago. So it's going to be up at some point. So it's going to be in that video. Otherwise, it's on my Twitch channel. If you go to my previous recording, it's in that one if you want to watch it there. Yeah. Okay. So that should work. We actually haven't tried spawning, so we need to test that as well. So now we can select rocks. And we select capsules. And if we deselect everything, no more errors. Perfect. Excuse me. All right, I think there might be another error. If we try to spawn now, yes, okay. We did get an error. If we try to spawn now, it works. Try to spawn mixed. That does not work, in fact. Okay, so it doesn't actually spawn the mixed meshes right now. So we have several problems. So let's go to the spawning function. Try spawn objects. So it's iterating through every spawn point, and the spawn thing is currently set to spawn prefab 0. So this is bad. We want to use the one in the data point again, right? So that's spawn point dot spawn data dot prefab, or spawn prefab. Actually, it's kind of redundant to have spawn in both of these words. So in this case, I'm probably just going to rename this to prefab because it's only ever going to be one prefab in these. Great. Let's see if that works. And spawn. And that works. So now it's doing random objects. Let's try with everything. Dude. Perfect. That looks neat. So, right, we had an error when spawning when nothing was selected. Let's see if we still have that. Yes, we do. Because it's going through every spawn point here, and none of them have a mesh, so they're all null. So I guess a quick way of checking that is if the spawn prefabs.count is 0, that means we have no prefab selected. So then we just want to return, right? There we go, recompile, and now we no longer have errors, right? Someone asked about the lighting, right? So some of you may have noticed that if you look at the lighting on the trees, they're very different. Like the trees that we are drawing kind of look like garbage, and the ones that are in the scene look all fluffy and soft and pretty, right? So how do we get the fluffy trees? If you remember when we talked about the draw mesh function, the draw mesh function we used was called draw mesh now. Draw mesh now kind of aggressively draws the mesh as soon as you run that command, and it ignores everything to do with the situation it's in, whatever matrix setup you have. It ignores your render pipeline. It just shoves the mesh into whatever your current rendering context is, right? And what that means is that these meshes are not actually part of the scene rendering, right? If we want to solve that, we can go to where we're drawing our previews. And then we have a function called draw prefab. And then we can also have the wrong function key set up. Right, so this is how we drew the mesh before, right? So this is one prefab. And then for every mesh filter inside of that prefab, we go to the child objects. We do some matrix shenanigans in order to transform it to the correct space. Then we get the material from the mesh rendering. Then we set the path of the material. So this is sort of like a global setting. So this is for like graphics.x commands. And in this case, we're doing graphics.drawMeshNow, right? So drawMeshNow, again, it just forces it to happen like immediately. But if we want to reuse the render pipeline, we need to use drawMesh instead. It has a few different parameters. So here we can specify a lot more things. So you can see that there's like a bajillion overloads here. So here's where we can set, you know, what layer should it draw on. Again, that's a render pipeline thing. We can set what camera to use. We can set what material property blocks to use. You can set what, if it should cast shadows and so forth, right? So now we're going to pass in the material, because that can be passed directly into those. So we don't need material.setPass again. The next one, I believe, is the layer. So we want to probably draw the default layer. If you go to the layer editor here, then default is probably the one that we want to set it to, right? I do believe that that's, I don't know if it's a mask. No, it's not a mask. Never mind. Right. So what we need to do now, though, is that we need to make sure that this only happens during repaint. So draw spawn previews. This whole function should probably only happen during repaint. And we do that. Okay, perfect. Will this stream go to YouTube too? Yes. So recompile. And now we are drawing a fuck ton of meshes, and that's bad. So now we sort of filled the whole context with meshes, which we don't want, right? But the light issue is fixed. That is true. We solved the actual problem. There's one more parameter that we're missing. We're not saying what camera to render this in. So we should pass the camera to this one. So that means that it's going to render in every single camera if we don't supply that. So now we pass what camera to draw this in, and now it's only being drawn in this camera, right? So now our lighting is actually matching up with the world. And then we can switch to the rocks. They're also matching up. And then capsules, and everything's looking good. So one of the assignments that you got was to make sure that things wouldn't spawn in case there's an overhang or something, right? So if there was, say, a cliff, this is how we make cliffs. Okay, so let's say we have some sort of overhang where we don't want things that are too tall to spawn underneath this one, right? So let's go to the trees. So you can see that this one, the trees are intersecting this object, right? So we don't want them to be able to spawn there. And let's add some more terrain so that we have more to test with. There we go. It is really frustrating that this is always visible. One thing that you would have to add to this tool is to make sure that you could like toggle the preview somehow, because it's really frustrating if you're like trying to do anything but place the items. If something is too tall, it still needs, it needs to check for that, right? So that it's like, if you have an overhang, we don't want to spawn trees under there, right? There are various places we could check for this. It should be when you, I guess when we generate the spawn points, because we do generate them every frame when you like move your cursor and everything. So in here, we can actually check the validity, right? You know, is this a valid position or not? So when we generate this one, we get a position, rotation, spawn date, and everything, but we don't know if it actually fits where we place it, right? So we need to check its validity. So how do we do that? So we have the case of like our hills and whatnot, and then we have some sort of overhang, right? But are you drawing in the background? I'm not. I'm sorry, I'm not a real artist then, I guess. So we have our trees and, we have our camera, right? And that one is looking at some spawn points, and that spawn point's probably somewhere here. And then we have a radius in which we want to spawn objects, right? So then we generate spawn points for every location, right? For all the places we want to put items. So then what we want to do is that we can check the normal of the surface to see how much clearance we have vertically, right? So if we know the height of the trees, we can get the normal, which is probably going to be something like this, because normals are normalized, which means that it's 1 meter. And then we can get sort of the height of our trees, right? Let's call that H. So if we can get the height of the trees, we can take the normal, normal n, and then multiply that by the height, which gives us a vector that is pointing all the way to the height of the tree if you would place the tree here, right? Well, it would be hopefully be to the top of the tree, right? Like this. So we would take the normal, multiply it by the height, and then that gives us this vector. What we can then do is that we can use this vector to raycast. So we raycast in the scene, and if this hits something within, you know, this distance, then that means that we don't want to place this tree, and that means that this is not a valid placement for this prefab, right? So there are multiple ways of setting this up, and like where we put the data kind of starts mattering quite a lot here, because it's kind of like tricky to know, you know, should that be something we calculate, or should that be something that we provide in each prefab, right? Oh, just to show an example, let's do that again here. So if we do that raycast here, then it would probably pass through this one, right? So that means that we are going to get a raycast hit at this location. So then that means that we're not gonna place something there, right? So this would be an invalid case, and this would be a valid case. Yeah, okay. So then there's, as usual, when you work with tools, there's always this balance of like, what does the user provide versus what do we calculate automatically, and what guesses and what heuristics do we use when designing this tool, right? Someone asked, collision detection of the tree and floating object, and then removing the tree is probably less efficient, right? So you wouldn't really remove the tree because it doesn't exist yet. We're only drawing the tree in the preview. But yeah, we could do that sort of, but the collision detection gets kind of tricky if you don't have rigid bodies, and if the collision detection is not about you know, moving rigid bodies that collide with some object, right? If it's just an object we place without a rigid body, then collision detection can get a little tricky. There are some functions that you can, like, you know, check if there are colliders within a sphere, but some of those functions actually use the bounding boxes of the objects rather than actually collision testing. So it gets pretty complicated. So I think the raycast method is not perfect, because if we're like, if we are right on the edge where the normal would point in this direction, so we get this vector, then the tree might still intersect, right? But what it is that it's really cheap still, right? Just a single raycast is much cheaper than trying to do like a proper collision detection here. Because like you can take it however far you want, you know? Like what if we have, could we sphere cast? You could, yeah. If you want like a volume of the cast. I don't know. I don't remember how accurate sphere cast is actually. Let me check. But yeah, that would give you a volume of it. There's also sweep test. I remember that there was one of the like physics functions that used the bounding boxes, and I'm not sure if that was the sphere cast. It shouldn't be. Overlap sphere, I'm pretty sure it might have been this one. I don't remember. But yeah, we could use sphere cast as well. I'm just going to use raycast for simplicity. Both probably work. I don't think it's broken. Okay, so let's actually implement it. So so the question is like, what is user provided and what is calculated? I think I personally would want this to be user provided, because sometimes we could use something like, you know, we have all of these objects inside of each tree, right? Actually, let's just draw this. Right. So we have this cylinder, right? That's kind of the stem of the tree, right? So this is the trunk stem. Trunk, right? It's called trunk. I don't know. How does English work? So you have this, the trunk of the tree, and then you have the leaves, right? And in our case, they're built of, this is a cylinder, and then the crown of the tree are all just spheres, right? But each of these are, you know, actual rigid bodies, or not rigid bodies, sorry, like actual colliders that we placed, right? Right, so, and each of these also have a renderer, so they're being rendered, right? So they would have some sort of collider, not all of them, right? And we could use like each individual collider and like do a, you know, rigid body sweep test of every single collider. But I feel like that's probably going to be excessively expensive for something that we don't really need it to be that accurate, right? The second thing is all the renderers. So we could possibly use the renderers for some of this data, right? So if we imagine each renderer, they all have a bounding box, right? The bounding box in world space. So we could read off of those bounding boxes. Something like that, right? There we go. What good bounding boxes? How do you like my bounding boxes? Okay, so now that we have the bounding boxes, we could use the bounding boxes for to calculate the height, right? Because we do have the all the data we need here, and we could use all the bounding boxes, and then we can, you know, figure out what are the extents of these bounding boxes. So then the meta bounding box we could calculate would be one that would encapsulate all of these bounding boxes, and then from there we could derive the height value, you know, from the bounding box, right? So we would get h here. This would probably work, right? But it works in this case, but there are cases where your bounding boxes are not even close to where you actually want things to be bound, right? Sometimes, you know, you could have, you know, say we have some leaves that are like fluttering in the wind or whatever, and that's a particle effect. And let's say that particle effect has like this bounding box. Then this would be this wouldn't really work. And then you might have, you know, you might have some, like, let's say you have like some leaves or something they want to like stick out of the tree, but they are like using quads for that geometry, and then there's like a, you know, leaf texture on this thing, right? But then, you know, the bounding box of this one is going to be you know, pretty far off from the leaves, and quite often you are okay with some intersection of this. So there are a bunch of edge cases for automatically calculating this that might not be worth it to like try to work around all the edge cases. So the other method is to sort of do this as a hand authoring thing. You have it as sort of this is kind of mostly viable for like internal tools for like your internal development, but it is okay to sometimes kind of explicitly define these things. Actually, let's bring this back. So what we could do is that for every object that we can spawn, we could add a component to it that just contains spawn information. So then spawn information could literally have a value for h. We can set the value to some given value, and then we can tweak this one to wherever we want it, right? So whatever things we might have sticking out of this mesh, we can set it to specifically cut off at some height when checking for if it can fit some region, right? Yeah, we also talked about having like a spawn radius So, that could also be part of that data where you also set the radius of, in which nothing else should be able to spawn, right? So it kind of makes sense to have that in the prefab itself, right? Where every prefab that you can spawn using the system also has the data for, what are the conditions in which we want this to be allowed to spawn or be disallowed to spawn, right? Sorry, that was like a super lengthy explanation for something probably simple, but yeah, so let's just do that. All right. So, let's create a script. So we can call this a SpawnablePrefab or something. So this one is mostly going to be a data container. We're just going to shove some data into this one that we're going to read only for the height stuff, right? So public float height, maybe set some default. And then it might be useful to draw that as well, right? Because you're not entirely sure how tall things are, and it's kind of difficult to check that. So let's make an onDraw gizmos. onDraw gizmo selected. So if you have this selected, you can then see that vector, right? So we want to draw a line, so we can do handles dot. Actually, handles are going to force us to use do editor branching and whatnot. Actually, not in this case. I don't care. Draw a polyline, and we want to draw that one from the root of this object, right? So that's going to be transform.position. And then we want to draw that along the y-axis of this object, right? Up by height, right? So that's going to be transform.up times vector, times height. There we go. All right. So now if we go to the tree, wait, why can I not double click the tree? Oh. I like how the Grim Cannon is like recasting into a ghost scene. You didn't add that to position? That is true. Thanks. Okay, so now we should add a component to this one, and that's going to be our spawnable prefab. So now there's a tiny little white line there, which is barely visible. So let's save some vectors. Actually, not 0. All right, so we have point A and point B. So we can draw a line. Then I also want to draw a sphere. I want to draw that at A with a radius of, I don't know. Oh yeah, actually, this is a good moment to talk about the, so quite often in Unity, the gizmos and whatnot are scaled depending on how close you are, right? So that they sort of have a consistent screen space size. So if we look at, let's back out of this one. If we look at our little dots that we draw here, they have a world space size, right? Because now they can get pretty large if you go close. If you move further away, they're tiny. You can't really see that there are dots there even. So there is a function in handle utility called getHandleSize. And in there, you can get a world space size of something at a position that will make it more consistent in screen space. So if we want to draw something at B, for instance, we can get the handle size at that point. There we go. And then we can pass that into each of these. I guess technically we should do this for both of these separately, because they can be at different distances from the camera, right? Okay. So now we're passing the handle size into draw sphere, and we're drawing A and B with their own respective handle size, right? So now if we go back to the tree prefab, recompile. So now we have these spheres being drawn, right? But if we zoom out, they become larger. If we zoom in, they become smaller. So this can be pretty useful sometimes. So it's way too big right now. So I'm gonna multiply that by something. And I really want to make a local function out of this now. Wait, there's no crate. Okay. Local functions are wonderful. Isn't this so much more neat? I love this. All right, so now we have the draw functions in one place, right? So now we can just add some multiplier there if we want it to be smaller. So I want it to be probably around a third of that. All right, so now we can, they're a little ghostly because they're inside of the mesh, right? But they're pretty visible on my end. Might not be super visible on stream. Oh, extract method has an option to be local. I thought that was separate from extract method, but okay. Neat. So now we can set the height value. Pulling the slider, you can see that this one is moving, right? So now we can set, this height value. Oh, and also if I move my camera away, you can see that the gizmo size is scaling to the screen rather than world space, right? All right, so I'm going to set this one to allow a tiny bit of intersection because I think that's fine. But as long as it doesn't like go, as long as the margin I have here is not larger than the thinnest objects I have in the scene, right? Okay, so now this one has a height. Can go back, see that this one has the height marked if I select it. But we need to do that for the other ones as well. So let's go to the capsule, add our component. That height is already perfect, so we're done with that one. Let's go to the rock, add component. That one is too tall. So let's reduce that one. That's probably fine. Okay, I think that's it. Now we need to implement this. So here we should now check if it's actually valid, right? So now we have the data for the height of the object. That's what we, everything we did here was to figure out height. And we kind of just decided that this is going to be something that you provide as whoever's going to set up the prefabs also set up the height, right? Oh, hey. Hey. How'd it go? Pretty good. Okay, neat.
I'm very hungry.
Right, so we need to check if this mesh can actually fit the current location. So we have all the data for the height. We have the normal as well, because we do have the rotation, right? And we can get the normal with the up vector. So, all right, let's do the raycast. Actually, we need the height value first. So float, can call it h again to match our drawing. So we can we do spawn data. We can do prefab, and then we do get components, SpawnablePrefab. So now we have a reference to the SpawnablePrefab, right? Actually, let's make a variable out of that. So one thing we might want to check here is that in case this one is a null, then we need to figure out what do we want the behavior to be. I think for me, I think I would prefer if it doesn't exist, it'll be allowed to place anywhere. Like it doesn't have any restrictions if this one is null, right? Because we need to handle that case. So if spawnable prefab is null, that means that this position is always valid, right? Otherwise, we need to check for all the restrictions for height, right? So here's where we need the height. So we get that from SpawnablePrefab dot height. And then we need to set up a raycast. So we can set up array equals new ray. And the origin of this one is going to be the position, right? The direction of this one is going to be the normal, which is up. And up, again, is our property that we have up here, right? I usually like naming properties with uppercase. I don't know what you prefer, but a lot of Unity's properties don't do that. So it depends on like what you want to stick with, I suppose. All right, so we have array set up now, and now we need to raycast. So if physics.raycast, we pass the ray into this one, and then we can also pass a max distance, and this is our height, right? So that's where we pass the h value into there. And then we have the out parameter for the raycast head, right? Actually, we don't even need the information that it hit, right? The only information we need is whether or not it hit, right? So if this one actually hit, that means that it is not valid, right? So what we can do is that we can set is valid to physics.raycast equals false. So if the raycast missed, that means that it's valid. If it hit, then that means that it's invalid. But we're not actually using this value right now, right? So even though we're checking all of these things, it's not in use at all. So let's make use of it. So that is wherever we're reading off of the spawn data. Let's see. I think the easiest place to start is that for the preview, we don't draw it if it's not valid. So then they will like disappear as we pull the cursor under the overhang, right? So maybe we can draw the little point still though. So if prefab is not null and spawn points dot spawn data dot oh, that's not, it's in there. So spawn point dot is valid, right? So if we have a prefab and the spawn point is valid, then we draw the mesh. Otherwise we draw the little gizmo, right? Now we have a UI error. We got a null reference exception here. Right, because the prefab can be null. I guess default should just be that it's not valid, actually. Validity has to be granted, apparently. Okay. I really want to use the null propagation, but that's bad in Unity. Right, so now we have our trees and they should disappear. They do. You can see that they disappear and then they reappear because they actually fit horizontally under our overhang. So that's some good news for those trees. So we can place those and, oh, did it place multiple? That looked weird. Yeah. Right, it also places even if they get obstructed now. So if you look at these two closest points that don't have trees, if I press space, they still spawn, right? So that's not good. So let's go to... where do we place? Try spawn objects. Okay. If spawn point dot is valid equals false, then we continue. Then we go to the next mesh, next prefab and see if that works, right? Or sorry, next spawn point. All right, let's try that again. Press space. Thor, no. Buddy. Oh, geez. I don't know if the stream is still up. Thor just pressed the power button. Mm-hmm. Yes, Thor. I love you, Thor, but sometimes it happened as soon as I pressed space to see if the spawning worked. I was like, oh no, did I press something? And it was like, no, this is Thor. All right, so we're back up. Cool. So let's try this again without shutting off the computer. And that seems to work. So now we had points close to the camera and it did not place trees there, right? There are a few other things that I would probably personally want to change with this. Like, I think, for instance, it might be useful to still see, like, what were the meshes that were obstructed, right? So you could, like, sort of jiggle a mesh out of some situation where it can't spawn, right? Because right now it's kind of like, they just anonymously disappear, but you're not able to see why they disappeared, right? So I think what I want to do is I want to set up a shader so that when it intersects, I want to draw like a red invalid transparent thingy. I think that would be kind of neat. So let's do that. Invalid spawn. That's a mean thing to call a child. All right, so I want this one to be transparent. We're getting a shader tutorial now, apparently. Trying to speed this through as quickly as possible. I don't know if you want me to explain it, but this is not a shader course, so. Okay, let's see if we can create an object and make a material. Excuse me. Oh. Thor has some opinions.
Be hungry.
There we go. Look at that little thing. I also wanted to do Fernell on this one. Let me just do that real quick. You know what I talked about these matrices and shaders quite a lot? Well, here it is. I actually don't know what the W component is in this one, so I'm just gonna make sure it's a 1. Hello, Thor. Hey, you're very close. Oh, heck, I forgot to open the student chat. Because Thor closed it. Okay, nobody said anything. Good. I was a little scared. Dude. Okay, we have the world position of the object. So here we're using a matrix to, because like when you're in a vertex shader, then you're kind of processing the vertex of the mesh, but you get that in local space. And just like we used tangent space before, where we transform from tangent space to world space, we can do that in shaders as well, where we transform every vertex from local space to world space. So that's what we're doing here with a model matrix. Yeah, so this is a matrix multiplication, a matrix multiplied by vector. So we're doing like a point transform, right? Yeah. So what I wanted to do was that I needed the world space position of the vertex, and then get that per pixel, and then get I want to get the Oh, I need the normal as well. I wanted to get the direction to the camera. That's kind of all I wanted to do with this. I think this is the name of Unity's variable. I always get this one wrong. It could be lowercase. I don't remember. This is something that sucks about writing shaders, is that you don't get any autocomplete, which is absolutely garbage. Oh, there we go. Okay, I got it. Whew. Close call. So we want to get the direction from the current pixel we're that's being rendered. So then we can do I dot world position, and then actually other way around. We want the direction from the surface to the camera. So then we would get that vector and then normalize that. This is usually called a view vector or a view direction in shaders. And then I want the normal of the surface. So I need to add that here. That one, I also need to transform into world space. Okay. So what happened here is that I'm transforming a direction rather than a position. So this kind of like makes it a 3x3 matrix, and then it ignores the position altogether. All right, so we can actually debug that by doing return. You're getting a shader tutorial. I don't know if you wanted this at all, but so now we're going to return the color of this pixel, right? So I'm just going to visualize the normal. So that's i.normal.xyz, and then alpha, we can set that to 1. So now this shader is outputting the normal direction of this mesh, right? This canon is bothering me. So if we can like replace this with any other mesh. Not that I have a lot of meshes in this project, but like the capsule as well. So now we're just outputting the normal direction, right? So what we want to do is we want to do the dot product between the direction to the camera and the normal direction. Oh, are all my tabs misaligned? So that would be i.normal, right? And the direction to camera. So we want to do the dot of that. And that's usually called a Fresnel that we're doing right now. The dot product between the direction to camera and the normal, right? So we can output that as well. And then we get this. So this is a neat little like hologram effect. It works best on stuff like cube or like soft edged stuff. If it's hard edged, you don't really get the same like outline vibe. So this one, it's more like, it's better for like rounder objects, but yeah. So it kind of depends on like what style and what kind of objects you want to use this for.
Objects that are longer than round.
What?
Objects that are longer than round.
Yes, that's what I want to use it for. Right, so usually with Fresnel, you often talk about it being more visible on the edges. So quite often you use it as this type of like hologram effect. There are also some artifacts if we zoom in. Might be hard to tell, but you might see some faceting here and here as well. And that's because we need to normalize the normal as well, because the normal, when passed to the fragment shader, is actually not normalized because it's interpolated across every triangle. So we need to normalize the normal. So now those artifacts are gone. Why is the effect more pronounced on curved objects? Because all we're checking is angle to surface. And on curved objects, we get a very like gradual change, which looks very continuous and nice. But on cubes, it's the same normal for like the whole surface. So we don't get that gradient, right? But with round objects, we get that quote unquote for free, right? Okay, so I wanted this to be sort of the effect that we were going to go for, and then this should be transparent and red as well. So we can multiply this by our color, right? Which is red. So I guess it would just be like we have the Fresnel value, or actually, we want red, and then the Fresnel value should be the transparency, right? Then we can go back. So now we have this vibe. So that's kind of neat. I think I might want them to be a little bit more filled in because I think the cube might look a little strange. The cube is actually sort of okay, but this looks really weird, right? When it goes fully transparent. So we don't want that to happen. So we can threshold this one. Or we can lerp this one actually. Because this Fresnel value is between 0 and 1, right? So that means that we can use it as a t-value in the lerp, where we want the minimum value to be a little bit more than 0, right? So let's say 0.1, and then maximum value should be 1 still. Then we can go back and recompile, and then we have an error because I wrote F in the shaders. So press F for errors. It's a bit too transparent still, I would say. There we go. So now we got this little hologram-y thing. I might actually want it to be a little bit transparent, even at the high end. Let's set that to 0.8. Maybe we'll lower this one a tiny bit. Okay, how about that? Isn't that neat? I think I might want to add an exponent to this as well, to change the curve a little bit, to make it a bit sharper. That's too sharp. Okay. There we go. What a hologram. Hope you enjoyed this shader tangent that we just went on. And then this tool type, of course. But hey, you might need these things in your tools, because we actually did that in this case, right? Alright, so this is going to be the shader that we want to use when things are invalid, right? When they're obstructed or something. Then we want to draw using this one. So let's delete those and go back here. Excuse me. Right. And then we can delete the material. Invalid spawn. There we go. So let's go back to our canon. So now what we want to do is that when something is invalid, that's when we use this material, right? But we don't actually have a material out of this now. So what we're going to do is that we're going to create the material when we open the editor window. So let's make another field. Material invalid. And then in onEnable, that's when we're gonna create this material. So then we're gonna do material invalid equals shader.find, and then you pass a path into this one. So the path is gonna be the path in the shader, not the folder path. That's really important to remember. So this is the path to the shader that we want, right? So unlit/invalid spawn. So that's what we're going to use there. So Here we go. And then we want to create a material out of this, right? So we can do a new material, and then we pass the shader into that one. Yeah, so now we've initialized this material. We do, however, need to delete this as well, because now we're creating an asset. Remember that we talked about assets, and that every time we create assets, you need to be careful to also delete them, right? So in onDisable, that is, when the editor window is closed, we want to also remove this material, right? So we would do that using destroy immediate material invalid. Okay. So now we should have this material, and now we need to go to our drawing function. So draw spawn previews, and in this case, we were not drawing in case the spawn point was invalid, right? But in this case, we actually still want to draw it. We just want to use a different material. So in this case, we probably want to pass a material to this one, right? Or actually, we can use that in draw prefab. Okay. So we want to check, excuse me, we want to check if it's valid here, right? So, this is going to be a long line. Let's split it up. Bool valid equals prefab dot, or no, wait, we actually don't have the validity here. Right, so never mind. We need an input parameter for that. So if it's valid, then we use the shadow material of the mesh. Otherwise, we use the invalid material. And this is a static function right now, so I'm just going to not make it static. So now we're branching based on validity, and we're passing the invalid material in case it's invalid, right? And then we're using that material here. So this should work. I might get a bunch of null reference exceptions, who knows? Right, because I never passed the validity here. So that would be spawn point dot is valid, right? There we go, and then we open this tool. We got our trees. It's rare that it didn't save the settings. It should have saved. So now we go under. We now get invalid trees. Look at all those red trees. They're telling us that that's not going to work. Yeah. So now we got a system for displaying invalid placements. I do think it's a little bit too it's a little bit too visible. I want to fade it a little bit. I think that's okay. So I thought it would be really useful to show some of the tools that we worked on at NeedCorp. So while I was there, there was like, we had a very big project, right? Where we're a small team and we had so many people, or so few people working on something like very big. So when we were working on budget cuts, we ended up creating many different tools throughout the whole development, right? So I thought it might be a good thing to see how, you know, how it looks like, you know, what a finished Unity project looks like, and the absolute chaos you have in your tools. Because it's, whenever you're in production, you don't have time to do like, generally you don't have time to make, you know, make the invalid placements red or whatever. You tend to hack everything to a very large extent because you need to reach your goal and you have deadlines, right? That doesn't go for all tools though. You need to make sure that they're still user-friendly and all of that stuff, right? So now I've got the project open for budget cuts. So this is the project that we worked on at Nicorp. So it's a released VR game. But yeah, so this is a finished project in Unity, and we worked on so many different tools for this. So I thought I'd just like, I don't know, run through a few things that we have in this project. So I guess one of the biggest, most like well-developed tool we have is probably the, wait, I don't work there anymore. Oh yeah, I also got permission from Nicorp to show all of this, so that's all fine. So one of them is for creating rooms. So we wanted to make sure that we didn't use like prefabs for everything. We wanted to be able to make the levels more dynamic and interesting rather than just like copy pasting blocks or whatever. So one tool is called Roomy, which is used to create levels. So you kind of, you can, you select walls, you can extrude rooms from those. And then you can rebuild to make rooms like this. In each of these corners, you can move those around and then rebuild. And then you start like creating environments like this. So this is an editor tool. Actually, I should probably, actually, it's not drawing the editor window, so rip, can't maximize that. So this one is used to create rooms of, all the rooms in the game is created using this tool. And there are like so many different like features in this for like, if you can create walls like this, if you click like that. There are a bunch of the connection tools. I show you the extrude one. If I create a wall, if I then select a wall and select a vertex, you can also project them against the wall they had selected. So there are like a bunch of different tools that we had to do in order to like be able to align things properly and all of that stuff, right? This is also the system we use for placing doorways. So if I search for doorway, that is also something you place. And then there's also like vents. I don't remember which one I should use. We have so many different vents. There we go. And then rebuild. And so now it's actually carved a hole in this wall, right? We don't really have lighting right now, so it doesn't look very good. We could build lighting, but that's going to take some time. So this one is generating procedural geometry for all of these walls, right? You can see that this is a mesh, and it's like carved a hole in this wall. And if I take this one and move it and then rebuild, it's going to regenerate that mesh. And the same thing goes for the floor. Like all of this is procedural meshes, and that's kind of that's something that's generated after you've placed all of these things, right? So if you create a wall segment like this, and then recompile, it's going to create a border around this pillar thing, right? Yeah, so this is probably one of the biggest tools that we had in this whole, for this game. It also supports like multiple stories. So if you say, have this room, we can also extrude that upwards, like so. Like that. And then if we rebuild now, it's now going to be a taller room, right? It also supports like if you like extrude like this, and delete that, we're now going to have a ledge into this room. So the connectivity vertically is sort of like calculated afterwards, right? You don't really explicitly define that, but if there are rooms overlapping, it just creates a hole there, right? And then we have all sorts of like texture alignment tools if you want to like align the floor textures. Yeah, a bunch of stuff like that. But yeah, so this is Roomy. It's probably the biggest tool we've had in this, and a lot of work went into this because there's a lot of things that you need to do, right? Let's see, what else? So one of one of the most important tools, I think, that we had in this project as well, aside from this one, is something called the scene verifier. So you can see that we have a big list of things in this one, right? So the scene verifier is meant to make sure that your level is sane, like make sure that everything is set up correctly. Because when you're in a big project, you have a small team with many features and many things that can go wrong in your projects and in your level specifically. Then it's good to have a tool that can like verify that, you know, are your key cards set up correctly? Have you placed reflection probes where you need to? All of that stuff, right? So all of that is checked with this tool. So you can click, we have like a thing where you can click check all, and then it's going to stop if it detects that something is wrong. So in this case, there are objects outside of our reflection probes. So then it tells you that, okay, you know, these objects are outside of the reflection probes, so we need to set up reflection probes, right? Could probably create one. All right, so reflection probe, and we have a specialized system in our case, because quite often reflection probes are, they're boxes, right? If you're within a box, the reflection probe is enabled, and then you can see those reflections off of your objects. But in our case, our rooms are not aligned with world, right? And they're not always boxes. So we set up a system for reflection probes within polygonal shapes, right? So they're, yeah, we call it polygonal reflection probes. So yeah, and then we have various tools for that as well. To remember where there we go, snap reflection probe to walls, which didn't seem to work. Oh wait, snap probe to room. There we go. So now it kind of adapted this shape for the room, right? And this is a tool you can edit as well. Like you can select individual points if you want to change the shape of this, which sometimes is required, and so forth. You can also delete points. You can also add points in between. So this is something that's pretty close to your assignment that you have with the pathing, where if you want to edit stuff in the scene and have multi-select and all that stuff, right? But yeah, okay, so we could snap those two. Go back to the scene verifier. So this would be like a very common process. You work on the level, you click check all in the scene verifier, and if something breaks, you fix that, and so forth, right? So check all, and now we passed pretty much everything because this level is very empty. This is kind of our template level. Yeah. So now everything's passed except Unity-chan. So we can open Unity-chan if we want to. Oh no, she's not working anymore. Why is it not working? Where's Unity-chan? Oh geez, I'm disappointed. I was so happy with Unity-chan. Oh well. Maybe it's because of the DPI scaling actually, because it's done in like UI coordinates. But yeah, so all of these things like check a bunch of stuff in the scene is going to be super useful to make sure that all of the things are valid, right? We had for Budget Cuts 1, we had a very specialized lighting system where we also baked light in our own custom baking process. So we also had that in the scene verifier where you could bake those types of like specialized stuff there. Other tools, we have a lot of like things for fiddling with components. So this is called Fiddler. So it has stuff for like, if you select a bunch of objects, you can press a button to group them in the hierarchy so that they're placed next to each other. Really good for sorting stuff. We have a remove colliders button, like lots of like micro tools like this. It's just full of micro tools. They're also, let's see if we can, so there's another system that we had for, oh yeah, I think the DPI scaling is what's messing this up actually. So let's, I think that's what's breaking Unity-chan as well. There we go. So we have these like models for bathroom pipes, and there are a bunch of models we have in this game that where we needed them to be able to connect to each other. And quite often connecting things to each other is kind of frustrating because you're like, ah, geez, do I need to like snap to grid and so forth, right? But we had a way to mark certain points of your mesh as a connectable source, right? So we have a system for connecting things to other things. If you select both of these, you can press connect and then to this, and then it connects to that one, right? So it's a very like neat system for setting up like more complex connectivity between objects, right? Yeah, so we have this for like fences, we have this for these pipes, we have that for vents, like a bunch of different things, right? It's interesting that the tool UI is in English. How so? Because it's internal and most of us speak Swedish, or? Okay, sort of running out of time. So if we go to, let's see, if we go to something like, so if we go to the budget cuts menu, for instance, so this one is like, we have a bunch of small things here, apply random scale, apply random Y rotation, delete all meshes in the scene, fix stupid Unity placing stuff wrong. So this is, I think it was Marco who did this one, where Marco was like really frustrated with things being like something about like weird happening with prefabs and being placed incorrectly in case some serialization thing broke. So this one fixes that. Yeah, so there's a bunch of different stuff. Marco is great at naming his tools. This one is called Mneh, just M-N-E-H. I don't know what that one does, but it's probably a great tool. There's apply rig shit for doing rig stuff. So Marco worked a lot on the AI and the locomotion of all the AI stuff, which is a lot of like animation and rigs and all the colliders attached to that, and that can get very messy. So there are a lot of like tools that that we make throughout this whole thing that are just like things we just rapidly create, and then we just don't care about like naming our tools or whatever. So let's see what else. There's some like third-party things here. So here's probably the biggest list of random tools that we have. I usually like naming the ones that I worked on silly things. I have Connie, Foldy, Buddy, Roomy, Fissy, but yeah, so all of these do different things, right? So there's a light map debugger, there's like a physics thing, there's a project verifier as well on top of the scene verifier. So the project verifier does stuff like deleting empty folders, because empty folders and Git does not work well together, because Unity generates meta files for empty folders, but if someone else doesn't have that empty folder, they're going to get the meta file in version control, but they don't have the folder, so Unity is going to delete the meta file, and then you have this like back and forth where you know, you're going to have like meta files for empty folders being bounced back and forth. So sometimes you need to set up stuff that, like, you know, changes stuff in your projects. Yeah, so there are lots of different things that goes into making a project like this. Oh yeah, you were working on patrol rights as well, right? So actually can show you how our patrol paths look. So it's a patrol path, and then the way we do patrol paths, I still say we do, but I don't work in Kneekerp anymore, so we did. I'm so used to it because I very recently left. Where are my gizmos? All right, so create an empty child. That's also a mean thing to call a child. So now we have this little point here, right? So the way this works is that the child objects of the this one is bothering me. The child objects of the component with the patrol path are the path points. So this is like a very, very simple way of setting up paths, right? So we can just duplicate these things and then drag them around. And the nice thing about this is that we don't need to deal with like selection stuff for, you know, selecting all of these points. And like doing a custom editor for that takes a long time sometimes. So So yeah, it's a pretty like simple but useful system. And then we have options for instance, if you want to change, right now this is like a back and forth path, but we can change this cyclic, so then these two connect as well, so then it will be patrolled as walking around. There's also another one, it's called roaming, so that one is going to walk randomly between all of these points. So after you reach a point, the AI is going to like find a random other point and then go from there, right? And then there's also sometimes we also have like patrol path info. So if you want like more information on each patrol point, you can set like minimum waiting time, maximum waiting time, the chance that the AI is going to wait at all. You can set the idle animation. So there are lots of like different configurations that you can set up per path point, right? Yeah. Let's see. Is there anything else? We have so many tools in this project. I feel like I'm not going to be able to cover all of them, but I should probably wrap up because we are taking Thor to the vet very soon. And I also need time to eat lunch at the same time. Okay. All right. Did I forget anything? Oh yeah, Unity-chan. Maybe Unity-chan works now. There we go. Unity-chan works. This is my favorite plugin. This is Unity-chan. Yeah. So this is if you want Unity-chan in your scene view, then yeah, there she is. Yeah. I really wanted to add like make Unity-chan talk to you if there's like an error or something, and she would be like, hey, you got a little reference exception and whatnot. Yeah, I would love to like sit down and do a proper version of this. I was considering messaging Unity Japan because I think this was on their website. So I wanted to see if I could make like an official version of this because that would be super fun because this is just an internal tool, right? But yeah, and some of my colleagues liked just having Unity-chan around. Oh, there was actually a side effect of Unity-chan that was really useful. What we noticed was that there's no way to tell, or it's kind of difficult to tell if you are compiling right now. And having Unity-chan just constantly animating in your scene view means that if Unity-chan is not animating, you're still compiling. And that turned out to be actually really useful, which was sort of a side effect of this. Because, you know, I just wanted to throw in this thing because I thought it was cute to have Unity-chan. But that was actually like, oh, that's kind of useful, actually, to like be able to quickly see, is Unity-chan animating? Nope, okay, I guess we're still compiling, right? Rather than like tiny, spinny, transparent thing in the corner of your console, right? Anyway, kind of most of the stuff. There are a bunch of like things in terms of like implementation if you want to like add a door with a key card reader, then you need to connect all of those things, but that's kind of just like standard component stuff. Any book recommendations? I don't actually have any good book recommendations. I generally, like whenever I want to like read for learning or whatever, I tend to not do that through books because there's usually more up-to-date information on the internet and there's lots of good resources out there. Unless you were talking about like literature or whatever, but I don't really read that much, so. Actually, the books by Sean Carroll are really good in case you're into like science and physics. Would recommend Sean Carroll. He's a good person with good thoughts. Any planning for Flowstorm game dev session soon? Yes. It's been a bit chaotic now around like setting up all the freelance work that I'm doing as well as doing this course for future games. But yeah, it's probably going to be next week. I don't know when yet, but yes, it's going to happen. I've sort of also been really focused on, I've been very focused, well, as of late, I've been working on Voronoi math, but I really want to get the my vector rendering library, my Unity vector rendering library out of the door. I want to finish that. And I've been like very focused on wrapping that up. All right, thank you all so much for joining. This is the last lecture. From now on, we're just going to do the rest of this day. It's going to be, you're going to work on your own. And I'm probably going to edit the video from last time meanwhile, because I still need to get that done. And then you can work on either the assignment that you got from the other teacher or the ones I've given you in case you want to practice those. And if you want, I can probably think of like more things you can do on this tool, because tool development is sort of, it's similar to game development in that you're creating something that people are experiencing and using, and you can polish it however much you want, right? Like you could add smoothing when you change radius. You could add, make the props appear and like wobble when you click. Like there are so many different things you can do for tools that that you would do in games as well. So it's kind of like this infinite well where you can just dig however far you want, right? Depending on how polished you want it to be. But yeah, as you can see in like a release project, things aren't as polished. They're more like, get the functionality up and running as soon as possible, make sure there's not too much overhead for whoever's using it, and then leave it at that, right? Okay, anyway, I really have to wrap up. If you want the other videos from this course, then feel free to go to YouTube. I uploaded part 1 and part 2 there. Part 3 and 4 are coming soon. This was part 4. And feel free to join our Discord if you want to like hang out in the community, a bunch of game developers, and a lot of us are under the LGBT umbrella as well. So if you want to talk about that, then that's also a good place for that. All right, I have to go. Thor needs to go to the vet. So thank you all so much for joining. And as for the students, I was going to say see you next time, but I don't know if we don't have a next lesson. But if you join my stream, then I will see you next time you join my stream, or if you join our Discord or whatever, wherever we might see each other next. But yeah, thank you so much for joining, and have a good day, night, morning, wherever you are.